Alright, hell yeah. So in this video, we're going to show how an inverse of a function retrieves the original input value of a function. And I think math gets hard where you're just like, oh man, that seems like juggling. Like my brain is literally kind of juggling this concept. The easiest graph to show this with is y equals x. And it also is the easiest one to show how you get an inverse. To get an inverse, you just you just kind of solve for x. So we solve for y. We're saying y is equal to x. X is the independent variable. We usually use a graph like this where the independent variable is horizontal and positive in this direction, and the dependent variable is positive in that direction. What this says is I'm going to incrementally increase the independent variable and say that I can put basically any number, 0, 1, 2, 3, and anything in between, and then I'm going to, when I do put that number into the equation, is going to give me an output. And we just know that functions can be any, the output could be kind of any number. We might not expect it to be, if we input 1, we're not expecting it to be just 1, but for a lot of different functions. But for this, one of the simpler functions, that's what we expect. And so we input a value of x is equal to 1, the y is equal to 1. What an inverse says is like, well, what if you take that output and then plug it into an equation, a new equation, that we create, and once we plug in this number into that equation, we're going to get the original input. So we're going to input this new value of 1 into this equation, and we're going to get the value x out. And that's going to be 1. We probably should have done this. Let's see if we can do this on the fly. Let's do it with one. We're going to do something that has a slope of 2. So this is y is equal to 2x. And then we'll actually get a c, because we can see from maybe symmetry. I don't know if we should do that first or second. But let's solve for this. If we solved for x, we're going to divide both sides by 2. And then we're going to have x is equal to 1/2 y. Cool. And then the thing to keep in mind is that this is our new equation. And so you can think of this as this is the y value. I'm going to say y prime is equal to 1/2 x prime. So, and that's kind of the change that's tricky. So if I graph this, and I'm going to say this is y or y prime, and this is x or x prime. And then so this is going to be, the slope is going to be 1/2. So I'm going to go over 2 up 1, over 2 up 1. And so that's what we have. And inverses will reflect upon the line y is equal to x, if it does have an inverse. Okay, hell yeah. And I don't know if we explore. Let's see what I did today. Okay, so y is going to be our function f of x. That's how you can write this function. And then this, our inverse function, is going to be represented as f to the negative 1. This is not, don't get this confused with f of x to the negative 1. This is going to be, hey, let's do this as an exponent, so this is 1 divided by f of x. But this gets used in trigonometry as well. If you take the inverse tangent of x, that's different than if you did tan x to the negative 1. This is 1 divided by tan x, and this is where, well, isn't tangent squared x? Isn't that just tangent x squared? Yes, but because we use it so often that we're going to put every power of trigonomic functions right there, except when you do that. You could put this right here, and this could mean that, but you would have to make it obvious. And I don't even know if what the the code is or the rule. But if you're using this to represent this, I would definitely, this is the only one that you shouldn't represent right there, and you should represent out there, especially if you're squaring, cubing, and if you're taking a trigonomic function to the -1 power, do it like that. But hell yeah, but there's a lot of mathematical symbols where this represents an inverse of some sort that doesn't have to just be 1 divided by that thing. And so this is one of them. Trigonomic functions are one of them. This is also one of them. So this does not represent just 1 divided by that function. If a function has an inverse, it can only have one singular value for each input. And so, and I can do this graphically. The one that's not going to work, the simplest one, is just y is equal to x squared. Because if you did kind of reflect this right here, so all you're doing is kind of reflecting this graph along the y. You could solve for x too. X is just the square root of y. But what happens when we get the square root of y? We get a plus and a minus. So now if I say this is y prime is equal to plus or minus the square root of x prime, and then I'm going to graph y and y prime and x prime, now this has 2 values. And that no longer is a function. The definition of a function is if I put in the value of 2, let's say if I put in the value of 4 into this equation, I'm gonna get a positive 2 and a negative 2. And so a function says you can only get 1 value. And so, and don't confuse that with y is equal to 5. Let's say y is equal to 5 or whatever. It seems like this contradicts, but no, x is equal to 3. When x is equal to 3, what's y? Y is equal to 5. When x is equal to 5, what's y? Y is equal to 5. This doesn't contradict the idea that if I choose x equals 10, I'm not getting this and that point. Like y isn't equal to 5 and y is equal to 10. Like that's not happening. So that's the definition of a function. You're going to every input, which is your independent variable, can only have 1 value output. So things that don't jive are vertical lines. So if you had something like this, a vertical line, and this was x is equal to 5, y could be any real number. And then so that is not a function from that sole definition. Okay, hell yeah. So let's see what we did here. And then we kind of go over that x squared one. And so it is a function. This is a function, you know what I mean? Because I can choose any value of x, and I'm just going to get 1 individual value. But if I reverse that, if I say when y is equal to 4, and then if I said y is equal to 4, you know, what are my x values that hit? It's going to be -2 and 2. So that's where, this is the horizontal line test. So sure, we're starting with a function that's x squared, but if I take a horizontal line and it hits more than 1 point, then it won't have an inverse. It could if you just do, here I'm just showing that, hey, let's just take this equation from 0 to positive infinity. Then this portion, yes, will satisfy that vertical line test. And then so its inverse is this. It's just going to be the positive value, not the negative value. So we're going to take the square root of both sides. This, yeah, and how do we say that? If I throw in, yeah, let's just see what we have. So this is the inverse function. It's x, the square root of x, or x to the half. And it's going to be just like that if we're just taking the absolute value or the positive of that. Okay, hell yeah. And so so here, if we took the actual equation of the positive and negative roots, 1, 2, 3, 4, when the value of x is 4, we're going to get an input of y of -2 and 2. And then that's why I took a pause, because how does the inverse work? It works like this. I'm going to choose for this equation x is equal to 2, and my output is going to be y is equal to 4. this is going to be my new input. And so that's where I'm going to get a new equation that this is the input. So that new equation is going to be maybe y prime is equal to something something x prime. And I'm going to say, hey, that's, and they don't do this in the textbooks, but just so my mind doesn't explode, that's what I'm going to do. Because I think it's very difficult to say y is equal to x squared and then solve for x. X is equal to plus or minus the square root of y. But still this works. Input 2 here, output 4 here. That 4 is your input here, so the square root of 4 is 2, and we did a full circle. But I think from a graphical perspective, you aren't graphing this in the same way. You're saying that this is a new y value, and this is plus. Alright, hell yeah, we ran out of juice there, so I got a new battery in. But hell yeah. So, yeah, y is equal to plus or minus the square root of 2. So this would be the inverse equation. So I would say this is f prime of x. So that's a better way to do it. So let's do that one, kind of using their convention. We're going to start with our first equation. F of x is equal to y is equal to x squared. I'm going to solve for x. That's going to be x is plus or minus the square root of y. And I'm going to say this is equal to the inverse. So there we go. So there's our two equations. F of x is equal to x squared. And then f prime of x, to the negative 1, the inverse to the negative 1. That's the sign that they're going to be using, is plus or minus the square root of y. This isn't a function because we can only, this is two functions, however you say that. But yeah, so that's why this one does not fail. This one fails the function test, because if I throw in a value of 4, I get a plus or minus 2. But this shows that x is equal to 2, outputs y is equal to 4. That's going to be my new input, y is equal to 4. My new output is x is equal to plus or minus 2. Alright, hell yeah. Cool. Alright, and then so, I guess, damn, we wanted to end with a difficult one. And do I have these even in the wrong order? Yeah, I think I have these in the wrong order. So we're going to end this video with a difficult one, and we're going to do the inverse of the exponential function. So we have find the inverse of an exponential. So here's a common exponential. Y is equal to the x. So that's an exponential function. This always satisfies the vertical line test, even if this value of x is negative, even if it's less than 1. This number to any value will did I say fail the no, this will, the vertical line test, this is a function, it only has 1 point. The horizontal line test of this function, it'll only hit 1 value. So this does have an inverse. But what's the inverse? How do you solve for x? That's where you have to use logarithmic, your log skills. So what is this? This is the base. It says we have a base of 2. How do you even do this? So if we have y is equal to 2x, I'm going to put in a value, let's just do one. I'm going to put in a value of 2. And so let's see what we do. Or let's see, I put in a value of, let's just play around with this. Put in a value of 0, and 2 to the 0 is 1. And that's the most critical part of learning math, is like if you don't know the rules, is just like, hey, can you play around with it and get there? You know what I mean? That's what I feel like. I'm on a deserted island, and it's just like, hey, I don't have any textbooks, but we can figure out what we've already known and probably more. So hell yeah. And so if I throw in a value of 1, 2 to the 1 is 2, 2 squared is 4. And so I can even plot those. So 0 is 1, 1 is 2, 2 is 4. Let's throw in a negative 1. 2 to the negative 1 is a half. Okay, because that's just 1 divided by 2 to the 1. And so negative 1 is a half. How about negative 2 for x? That's going to be 1 divided by 2 squared. That's going to be 1/4. And then so we can see that this never actually is a negative number. Even though I'm throwing negative values of x, that just means that we're taking 1 divided by 2 to that power. And so this is the function that we get. Okay, so let's try, what did we do? Let's throw in, let's use this one, 2. So 2 to the, when x is 2, we got 2 squared is 4. When y is 4, what would we do to that to get back 2? And like 2, like 4 to the what? And do you even say it like that? And no, you don't. You know, this was 2 to a power is 4, but we don't get to do that. We don't just get to say 4 to what power is 2. We have to say this 2 to oh, this is tripping me out. Alright, let's just say it. So this is the inverse. If you have y is equal to 2x, your inverse is oh, and that's, yeah, we should probably do a mathematical step here, because I at least know, yeah, logarithms suck because you're just like, I know the rules, but I don't know tangible ways to explain them. But if I have this, I'm going to take the log base 2 of both sides. So log base 2 of 2 to the x. What does this do? If these are the same, it brings down the x. So this is x, and this is now log base 2 of y. So we have just solved for x. This is going to be our f inverse function. So our f inverse function of x is, well, I'm just going to say our, do you say this f inverse of y? Well, let's just use x is going to be log 2 x is equal to y. Even though, I probably shouldn't have done like that, but let's do them both. Log base 2 of y is equal to x. So our initial input was 2 to the x, and I put in a value of 2. 2 to the 2 is 4. I'm going to take this value of 4 and then put it into this function. And we're going to take log base 2 of 4. And what the hell does that even mean? You know what I mean? Let's try it. So we got log base 2 of 4 is equal to x. And this is where, just like the first thing in logarithms is to pick out your base. I think that is. And if you have natural log and then some sort of x value, y value, there, you know, you can say this is log base e to the x. That's why natural logs make it even harder, but there's your base for a natural log. Hell yes, this is our base. So write that. Even just write out the word. So we're going to have base. If you do have a base, you're going to have an exponent. And then you're going to have a value after that. And so what I do is I do 2, and then my exponent is usually what I'm trying to solve for, and then this is the value. And so I have 2 to the what is equal to 4. So that's how I read a logarithm. Base of 2, and then I just know that this side is your exponent side. So I know that this is the base, this is the exponent side, and I think it's very useful to know just 1 or 2 common logarithms. The one that I use is log base 10 of 1,000,000. Write out all these zeros for 1,000,000, and then just know that's 6. And just know that the log base 10 of a large number generates the smaller number, which is just representative of the zeros basically. And so this allows you to know that, hey, like even if you have natural log, this is your larger number, and this is your smaller number because it's your exponent. And I'm gonna do one if you had to solve for the square root of 25. Like, what's that? Like, I do this. It's a number times a number. This times this is equal to 25. So what makes that make sense? And, you know, we don't do that a whole lot with, you know, square roots. We just kind of know what they are. Cube roots, we just kind of know what they are. Cube root's going to be 3. But what if you had, and this is going to be, you know, 25 to the 1/3 power. This is 25 to the half power. What if you had 25 to the, you know, 0.312 power? You know what I mean? And then what do we do there? That's going to be for a separate video. But it's just good when you're doing logarithms to be like, and yeah, let's go through this. So we're going to have y is equal to 2 to the x. X is going to be 4. We're going to have 2 squared, and this is going to be 4. So our y value is 4. Then we're going to go log base 2 of is it 4? Yeah, log base 2 of our y value is our x value. You know what I mean? Another sheet, but yep. And then so we're going to have, so this thing is 2 to the what value is equal to 4. And then so this is, that value is 2. So that retrieves that original input. Again, we started with an x input of 2. 2 squared is 4. We use this equation. We take that 4 and put it into a an equation, and I probably should have, even though you write it like this, if we're going to write this is our inverse equation to whatever, it's going to be like this. Log 2 of y is equal to, sorry, and I don't, yeah, that's bugging me, because again, if we have y is equal to x and we solve for x, we're going to have x is equal to y. But this is a new equation where we can say, hey, this is y prime and this is x prime. You know, this is going to be f inverse x, and then this is going to be f of x. So this keeps our independent variables always x, and we can graph them on the same line. And so that's the tricky part, to kind of, you know, solve for x, but then switch variables. And especially for that one. So should we mentally walk through that one more time? We have y is equal to 2x. I'm going to put an x value is equal to 2. Well, and then we just need to know the inverse of this. The inverse of this is going to take the log base 2 of y and then log base 2 of 2 to the x. This just brings down the x, and then we solve for x. And so I'm going to have x is equal to log base 2 of y. I'm going to switch variables and say this is y is equal to log base 2 of x, or say this is inverse of the equation log 2x, where the original equation is 2 to the x. Hell yeah. Alright, so so that means that if we throw in a value of 2 there, we get 2 to the 2 is 4. This is our input into our new equation, which is that one. And we have log 2 of 4. What does this mean? We have to set it up. We have to say 2 to the exponent, and this is the exponent. This is what we're trying to solve. 2 to the exponent is 4. And then we have to just guess and check, or use tables, use our calculator, 2, or just, if it works out, 2. So this value is 2. And that's what we expect. We started with an input of 2. We got a y is 4. We're going to use that as our new input into an equation. And we output that value of 2, which was our original. And so the hardest part about this is like, yeah, it's just that y is equal to x, solve for x, x is equal to y. This is a new equation where we're going to say it's just maybe y prime is equal to x prime, where this value of x is y prime, this value of y is x prime. That's a pretty decent way. Alright, so hell yeah. I was trying to make shorter videos by showing you what we're doing, but that's the last page of this. And And I did have a page of plotting. Yeah, and I think we should go over that because this is the trickier part. We got 5 minutes of, 30-minute video. Okay, so we have these two equations. Let's choose a value 2 to the, what do we know? 2 to the 0. So 2 to the 0 is 1. And so this represents that. And then this inverse represents a dot with a negative 1. So here's the dots with the negative 1s. And this was a mistake, I think. Yep, that was a mistaken point. So when I throw a value of x is equal to 0 into this equation, 2 to the 0 is 1. Cool. Let's throw a value of negative 1. 2 to the negative 1 is 1/2. So this is our x value of negative 1, and we got a half. Oh yeah, let's for each of our inputs, let's find the inverse. So x value of 0, 2 to the 0 is 1. That's going to be our new input into this. So that's our y value is 1. It's going to be our new input into this equation. So this says log base 2 of 1 is equal to what? And so how we say that is 2 to this exponent is equal to the value, 1. So 2 to the what is equal to 1. 2 to the, well, if we square rooted this, what the hell? It has to be 0. 2 to the 0, yeah, 2 to the 0 is 1. So there you go. And then that's where the input of this one was 0, the output was 1. The input of this one was 1, the output was 0. So those two, I'm going to say A. Let's hopefully go the easier direction. Input of 1, 2 to the 1 is 2. And then this output of 2 is going to be our new input. So this is our x value of 2. 2 to the what is 2. 2 to the what is 2. This has to be 1, which was our input. So this new equation, our input is 2, and then our value output is 1. So there you go. So this point is right there, and this is our first equation. This is the inverse equation. All right, now let's go the other way and be done with this video. An x value of negative 1 right here. That's going to be 2 to the negative 1 is a half. That value of a half is going to be our input into this equation. We're going to have 2 to the what is a half. 2 to the what is a half. Like, yeah, and it's good to even though we're doing a pattern, it's just like, I don't know. Oh yeah, 2 to the what is a half? Well, it would be a negative 1 because I want to take 2, I want to do that to it. So I'm going to divide it and then multiply it by the power of 1. That's what a negative 1 does. It's 1 divided by 2 to the 1 power. Hell yeah, and that's what we would expect. Our input over here was an x value of 1. We outputted a half. When we throw in a half here, this is going to be 2 to the negative 1. And that means that our value, our output, is a half. So the input is negative 1, the output's a half. So I'm going to go to a half and find, that's going to be our new input, and then our output's negative 1. So there you go, C and C. I should probably do that one more time then. We're going to do input of x is equal to negative 2 into this equation. 2 to the negative 2. That's going to be 1 divided by 2 squared, which is 1 divided by 1/4. So that's inputting x negative 2 into this equation gives you 1/4. That 1/4 is going to be the input into this equation, which says 2 to the what is 1/4. Well, I need to do this. Put this downstairs and then square it. And so we do that by putting a negative 2 right there. So that's the value, that's the output for this equation. If this is a value of 1/4, the input was x is equal to half, the output was 1/4. That's going to be our new input into this equation. Our output is going to be negative 2. And so that's what we see. And hell yeah, so this is going to be our new output. or yeah, x into this equation, we get the 1/4. We're going to take that 1/4 and then input it into this equation, and we get -2, which is right there. Whew. So yeah, it's just kind of interesting that the inputs start with an input of an independent variable, get an output. That output becomes your new independent variable. That's what I was struggling with. This output becomes your new independent variable right there to the new equation, and that gives you an output. All right, so hell yeah. It's mentally complicated just because you probably have to switch variables. You know, you can solve for x, but then when you do solve for x, switch variables. This was the original x, and now this is a new, and this was the original y. You know, something like that. So, alright, hell yeah. We ran out of juice, but that's it. That's the end of the video. So thanks for joining me on this one. Booyah.